Hello, I'm going to be reviewing Monday's assignment, Monday, May 18th, on Gay-Lussac's law. So number one, write the equation for Gay-Lussac law in the box below. Initial pressure divided by initial temperature equals the final pressure divided by the final temperature. P is pressure, T is temperature. The problems always give you the temperature in Celsius, but you must convert it into Kelvin. Okay? I'm going to erase this so I have space for number 2. So, come on, write it down in your notebook, piece of paper, loose leaf, number 2. The pressure, I'm going to write the law at the top right here. So I always have it here for reference. Okay. So number 2, the pressure of an automobile tire is 1.88 atmospheres. The pressure, P1, 1.88 atmospheres. At 25 degrees Celsius, the initial temperature is 25 degrees Celsius. What would the pressure be? So that means we're solving for P2. If the temperature increased, so T2 equals 37 degrees Celsius. Remember, temperature must be in Kelvin. Let me use a different color. In order for me to convert into Kelvin, I must add 273 plus 273. So now that new temperature for T1 is going to be 298 Kelvin, and then T2 is going to be 310 Kelvin. So now we're going to plug in to our equation. So P1 divided by T1 equals, we don't know P2, I'm going to put an X, divided by 310. Okay. Cross multiply. And then your final answer should be 1.96 atmospheres. Okay. So that's number 2. Moving on to number 3. A gas in a sealed container has a pressure of 125 kilopascals. So that initial pressure, 125 kilopascals. At a temperature of 30 degrees Celsius. So T1, 30 degrees Celsius. The question asks if the pressure in the container is increased to 201 kilopascals. So that new pressure now is 201 kilopascals. What will be the new temperature? So we're solving for T2. Okay. So again, the temperature's in Celsius. I have to add 273 to get it into Kelvin. So that new temperature is going to be 303 Kelvin. So P1 is 125 divided by 303 Kelvin. You're not going to put 30 degrees Celsius. It needs to be in Kelvin. Equals 201 kilopascals divided by X. Cross multiply, and then you'll find that your final temperature should be 487 Kelvin. Some of you are getting the right numerical value but have the wrong units. Temperature must always be in Kelvin. You can convert it back into Celsius if you want, but I see people put in 487 degrees Celsius. Wrong, Kelvin. Okay, moving on to the Last question, number 4. A sample of gas has a pressure of, a lot of you got this one wrong. So let's review it. A sample of gas has a pressure, so P1, 700 mmHg at 30 degrees Celsius. Okay. The question asks, at what temperature? So we're solving for T2. Would the pressure be 600 mmHg? So P2 would be 600 mmHg. And I feel like it was like some math problem. Like you're messing up on your math. So we're going to add 273 to convert that to Kelvin. And then once I add, my T1 should be 303 Kelvin. Now I put my values into the formula. 700 divided by 303 equals 600 divided by x. You multiply these two, multiply that. 700 times x is 700x equals 303 times 600, and I will get 181,800. If I divide both sides by 700, then I'll find that my final temperature should be around 260 Kelvin. Okay. So this is Monday's assignment. Please check over your work. If you did not receive full credit, do it over so you could get full credit. If you have any questions, write me on Jupiter.